Could a human being outrun a dinosaur? Dinosaurs have thrilled and fascinated us since they were first discovered more than 150 years ago. When Gideon Mantell found the remains of Iguanodon, he was the first person to sketch how a dinosaur might have looked when it was alive. Since then, museums all around the world have been collecting specimens, gradually building our knowledge of how dinosaurs might have looked and behaved. There was a wide range of different dinosaur species, each specially suited to its own habitat. Some, like the fearsome Tyrannosaurus rex, were predators, with razor-sharp teeth and claws to destroy their prey. Others, like Triceratops, were herbivores. They only ate plants. Many dinosaurs had fins to keep cool in hot climates and to protect themselves from attack by meat-eaters. The Earth was formed 4.5 billion years ago, but it was very different to the way it is now. Life eventually began to flourish, but it wasn't until 250 million years ago that dinosaurs first appeared. They ruled the planet for nearly 200 million years, then apparently died out around 65 million years ago. Nobody has ever proved why dinosaurs disappeared. We can still only guess. Homo sapien came into existence just 1 million years ago. Imagine that it's midnight and life on Earth started just 12 hours ago. On this timescale, dinosaurs appeared at 7 o'clock and died out at 11 o'clock. Human beings have only been around in the last few seconds. We have a long way to go before we've survived for as long as the dinosaurs did. But if dinosaurs died out long before humans even existed, how can we possibly find out how fast they could run? In 1865, Charles Darwin put forward his theory of evolution. His idea was that all life on Earth had evolved, that every species had gradually changed over millions of years, adapting themselves to each new environment. Some animals have died out, but their closest relations live on. In particular, he believed that humans had evolved from apes. Scientists now believe that humans and chimpanzees have the same ancestors, but that we went our separate ways about 5 million years ago. Suppose some dinosaur species didn't become extinct, but evolved instead. We could learn about the way dinosaurs ran if we could find their modern-day descendants. By examining its skeleton, we know that Allosaurus ran upright on 2 legs. We also think that dinosaur young hatched from eggs, and that's your second clue. These are the fossilized remains of Archaeopteryx, first found in Germany in the 19th century. Like other dinosaurs, Archaeopteryx had many of the features of reptiles: teeth, claws, and a tail. But Archaeopteryx was a special discovery. It's the missing evolutionary link between dinosaurs and their modern relatives. The real giveaway is the imprint of feathers. We now believe that all modern birds are descended from Archaeopteryx. Ostriches can run at up to 65 kilometers per hour. By studying modern-day birds like these, scientists have worked out a formula for how fast they can run. V is the speed, S is the stride length, and L is the length of their legs. The point is, if you know an ostrich's stride length and leg length, you can work out its speed. Suppose we assume that the same formula works for dinosaurs. If we could find out Allosaurus's stride length and the length of its legs, we could use the formula to work out how fast it could run.
Got to measure it from the hip down.
The first thing to do is to measure an Allosaurus skeleton.
2.2 meters.
So from the top of the hip to the ground is 2.2 meters.
That's L, one of the things they need to know for the formula. They're also measuring the size of the Allosaurus's foot. They'll need this later.
If you hold the string up.
That's it.
That's 55 centimeters.
The other thing they need to know for the formula is the dinosaur's stride length, and they can get that from footprints. There are fossilized dinosaur footprints all over the world, from Oxford to Oklahoma. There's a replica set of footprints outside the museum. They're trying to decide on the size of the dinosaur that made these prints.
The dinosaur must have been running like this. It must have gone like that.
The back
So it would be like that and it's gone like that.
Yeah, so
So if we measure from there,
if it comes down here, it must go
there, stop from it. So he measured from here to here. Right here to here, so...
Yeah. That's a good foot flat though, isn't it?
Yeah. And like, Mum called like 50 centimetres.
About 50 centimetres, yeah.
The footprint is about the same size as the skeleton's foot, so the Allosaurus that made the footprints is about the same size as the skeleton.
That one.
Now they're ready to measure the stride length.
Look, I found another one, over here. Why don't we measure from this one to the other print?
No, straighten it up. Yeah. 2.5. It's 5 meters.
The stride length is the distance between the footprints. It's about 5 meters. That gives you some idea how fast the Allosaurus could move. 5 meters is much bigger than a human stride length. Now they know L and S, they can replace these letters with numbers in the formula. The leg length L was 2.2 meters, and the stride length S was 5.0 meters. Plugging these numbers into a calculator gives V equals 13.5 meters per second. That's about 50 kilometers per hour. Allosaurus was pretty fast. We know Allosaurus was fast, but how fast are security guards? When photography was invented, it gave us a great way to study animals.
Would you mind getting changed into these, please? The changing rooms are over there. Thanks.
Right.
After all the cameras have been focused, they're ready to start. With 10 cameras and several runs, they have plenty of pictures to sort out. When you're trying to get the pictures in the right order, you learn a lot about the way humans run.
No, because it'd be over there if we were first.
Yeah, look, he's lifting off
like that
there,
there.
isn't
Yeah.
it? Look, he's already got his foot there, that's first, and then he's lifting off his foot. That must be after this one.
Yeah.
Right.
Yeah, but if you landed them...
Wait a second, I think he's got his foot down there and he's lifting it off there. Think that?
Yeah.
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 While they're thinking about it, the security guard gets some training in.
That one's up here. here somewhere.
It's got to be up there, because if his foot's been there, then he's got to be somewhere back there.
It's in between there. Because
he's in a jump there, and he's landed there.
Right, and the last one there, he's already landed there, so that's it done.
Try this experiment yourselves. You don't need expensive cameras, and it'll really make you think about how the legs move. So why do we run the way we do? The bones inside the leg support the whole body. They're strong enough to take all the weight. The joints between the bones allow the leg to bend as it moves. As well as allowing movement, the joints help protect the bones from damage. Inside the knee joint, cartilage acts as a shock absorber. It cushions the impact every time the foot hits the ground. The bones work together with muscles to make the leg move. Muscles often work in pairs. In this pair, you can see that one muscle is thin and relaxed, and the other one is all bunched up. When the thin muscle bunches up, it pulls at the knee joint and makes it bend. To make the knee straight again, the other muscle bunches up. It needs two muscles, so the knee can bend both ways. Other pairs of muscles move different joints in the leg. Muscles, bones, and joints work together to move all the limbs. But how fast can they carry a security guard? Only about 20 kilometers per hour. But it looks like you'd rather face Allosaurus than any more scientists. Humans, ostriches, and dinosaurs have different bones.